Hey guys, today we're going to be looking at the 2016 December contest silver problem Moocast. In this problem, we have n cows that are spread across the field. These n cows are trying to communicate a message to each other. And each cow has a walkie-talkie. The walkie-talkie has power P. And each walkie-talkie can transmit to every cow up to the radius of P. In the input, we're given the number of cows, the coordinate of each cow, and as well as their power P. And our job is to find the maximum number of cows a broadcast from a single cow can reach. To understand the problem better, let's draw out the sample input. So I already have a graph here, and this basically is the sample input. The dots mean the cows, and the circles mean the radius which the cow can transmit. So in this case, A will be able, if we start from A will be able to transmit to B because B is within the radius. B will be able to transmit to C, and then it will stop because C cannot transmit to D. So our answer would be a total of 3 cows. So how do we go about solving this problem? Well, first of all, we have to know which cows can broadcast messages to each other. So let's say we started at point A. How do we know if point A can be able to transmit messages to point B? Well, we need to know the distance between these 2 points first. And to find the distance, all we need to do is to draw a right triangle between these 2 points. And the length of this is going to be 5 minus 1, which is going to be 4. The length of this is going to be 4 minus 3, which is going to be 1. So our total length would be the square root of 4 squared plus 1 squared. This is the Pythagorean theorem, which will be equal to 16 plus 1, which is equal to the square root of 17, which is approximately equal to 4.123. And because this number is less than our radius for A, which is 5, because this is 5, because it's less than 5, we're able to transmit messages to point B. And because our n is less than 200, we can get every cow that a cow can broadcast to. So for A, we can broadcast to B. For B, we can broadcast to C. And for C, we cannot broadcast to anyone. And for D, we cannot broadcast to anyone. So using this array, we can try from every cow to see how many cows they can reach. So if we start from A, we see that A can reach B, B then can reach C, and C can reach nothing. So that would end up with 3. And for B, B can reach C, C can reach nothing. So that would end up with 2. And we can do this using BFS for every cow, which would be 200 squared, which would give us 40,000, which will be sufficient for the time limit. Let's look at the code for this to get a better understanding. So I've already set up a struct of cow, and this cow is going to have the properties of x, y, and the range of the walkie-talkie. And we also have a boolean visited, which is currently set to false. We're going to use that later. Then I have a distance function, which takes in 2 cows and basically calculates the distance. So to calculate the distance, all we need to do is we're going to get the distance of x, and we're going to square that, and then we're going to get the distance of y, and we're going to square that, and then we're going to add them together, and then we're going to square root. So first of all, I read in n. I'm going to make a vector of cows. And I'm going to cycle through n. Each time I'm going to initialize the vector cows. And then we're going to read in the x, y, and range values. Now we're going to construct a can reach vector, which basically stores all of the cows that a cow can reach. So we're going to cycle through each cow to do this. And for each of those cows, we're going to cycle every other cow. So basically, we're getting every possible pair. And then we're going to calculate the distance between those pairs. We're going to check if the distance is less than the first cow's range. And if it's less than the first cow's range, we're going to say that the first cow can reach the second cow. And if the distance also smaller than the second cow's range, then we're going to say the second cow can reach the first cow. Now we're going to try to use BFS to get the maximum number of cows that can receive the broadcast, starting with a single cow. So first of all, we're going to define our result, and we're going to cycle through each cow. And for each cow, we're going to start with that cow. So we're first going to make a queue, and then we're going to add the index of that cow. Then we're also going to use visited, and we're going to set that to true. We're also going to have a count, which tells us how many cows already got the message. So we're going to say every time the queue is not empty, we're going to get the current cow, and we're going to pop it from the queue, and we're going to add count, because we know that that cow received the message. Then we're going to cycle through each neighbor of that cow in the can reach array. And if that neighbor is not visited, then we're going to add it to the queue, and we're going to set the visited to true. And that's pretty much it. All we need to do is max the result. So we're going to take the max of the result and the count. And we should be able to get the maximum of every count, which will also be our final answer. Although this problem is a bit complicated, we're able to break down each step and solve the problem. Hope you guys enjoyed the video, and I'll see you in the next USACO problem.